Students, good afternoon. I am so happy to see you once again. My today's class is capillary action in air drying. Capillary action, liquid diffusion and vapor diffusion, these are all the mechanism of drying in falling rate period. Among the three, in today's class, I am going to discuss about the capillary action. What is the mechanism behind the capillary action? Capillary action is nothing but, consider a wet solid. Solid contains certain amount of moisture or liquid water. Clear? Capillary action is nothing but movement of moisture towards the outer surface of the solid through pores. Clear? Movement of moisture within the pores. Movement of the moisture within the pores by surface tension and adhesive forces of interaction between walls of the pore walls and surface of the moisture. So capillary action is nothing but movement of moisture within the pores by surface tension and adhesive forces of interaction between walls of the pore walls and surface of the moisture. Clear? So capillary action is nothing but movement of moisture within the pores by means of surface tension and adhesive forces of interaction between walls of the pore and surface of the moisture. This is the capillary action. In falling rate period, the rate of evaporation of moisture in the outer surface, will not be equal to rate of movement of moisture towards the outer surface. In falling rate period, listen, the important point is rate of evaporation of moisture at the outer surface will not be equal to rate of movement of moisture towards the outer surface. Clear? In falling rate period, rate of evaporation of moisture in the outer surface will not be equal to rate of movement of moisture towards this outer surface. It will be less value. Rate of evaporation of moisture at the outer surface is greater than that of rate of movement of moisture towards the outer surface. Clear? In such a situation, movement of moisture towards the outer surface, movement of moisture towards the outer surface is only by means of capillary action. Only by means of capillary action. Movement of moisture through force. Movement of moisture through force is because of capillary pressure difference. Difference in capillary pressure. Movement of moisture through force is because of difference in capillary pressure. Clear? Once the droplets of water are moisture towards the next pore, this pore will be empty. There will be a suction pressure. This suction pressure sucks the moisture from the next pore. So movement of moisture through pores is because of difference in capillary pressure or difference in capillary suction pressure. For small and fine pores, the capillary suction pressure becomes vital. Capillary suction pressure will be predominant, will be strong suction pressure. Clear? For a small and fine pores, the capillary suction pressure will be vigorous or very strong. Clear? This is the case in falling rate period. As drying under progress in falling rate period, as drying under progress, the continuous liquid film within the pores, continuous liquid film in the pores will be disconnected or it will be broken down at one fine point. As drying under progress, at one fine point, this continuous liquid film present in the pores will be broken down. From that instance, liquid diffusion as well as vapor diffusion will be predominant. Clear? Capillary action is nothing but movement of moisture within the pores by means of surface tension and adhesive forces of interaction between walls of the pore and surface of the liquid. Clear? In falling rate period, drying at the outer surface, I mean the rate of evaporation of moisture at the outer surface will not be equal to rate of movement of moisture towards the outer surface. Rate of evaporation of moisture is more than that of rate of movement of moisture towards the outer surface. In such a situation, movement of moisture through pores, movement of moisture towards outer surface through pores is only because of capillary action. Capillary action is nothing but capillary pressure difference, difference in capillary pressure. For fine and very small pore structure, this difference in capillary pressure will be more, suction pressure, capillary suction pressure will be more. Clear? This is the fundamental behind the capillary action. Clear? As drying under progress, the continuous liquid film will be broken down at one fine point. At that point onwards, liquid diffusion, vapor diffusion will be more predominant. In my next class, I will continue with the liquid diffusion and vapor diffusion. Thank you.